Hey everyone, it's Mr. H here. Gonna move on to 8.2, which is all about the law of cosines. So a new set of formulas. You'll use these formulas for the other two cases. So case 3, the side angle side, and case 4, side side side. So it's really 3 formulas, but they're all pretty much the same structure. The thing is, notice when you have the side over here by itself is opposite the angle that you input there. And then the other two sides are the sides that are adjacent to that angle, right? And that's the same structure for all of these. So if you're trying to find B, then angle B goes there. And then the two adjacent sides to angle B are the other two values in the formula. Okay, so in the rest of this front page, these are the cases just as a summary from the previous section, the law of sines, those two cases, and then the two new cases are here. And I've provided just the steps involved in all of those cases. So it's a good reference page as you go through. So we'll jump into some examples. One thing that you'll see is you have to decide what case you have, and based off of the case, do you use law of sines or law of cosines to begin? So for example, this number 1, if you know those 3 things, right? You know little a, little b, and angle C. What case is that? Oh, Sun's game. And what law? Okay, so if you know, here's a little triangle that's useful. We know those 3 things. Notice you know side, then you know an angle, and then a side. That's side angle side, right? So that's SAS. And anytime it's SAS, if you look back, that's this case 3, which you start by using the law of cosines. So this would be law of cosines. And that's all we're doing. So just practicing that. What case do you have and what's the law? And again, it's always this same structured triangle, right? Little c is opposite big C, etc. So how about, and then lowercase are always the sides, uppercase are the angles. So if we have A, B, C all lowercase, that's 3 sides. That's side, side, side. And that's case 4. So that would also be law of cosines to start it off. What about this one? You have A, B, C. So you have 2 angles, right? A and B. And then you have C, which is the side between those 2 angles. So notice how that is angle, side, angle, right? So that's ASA, angle, side, angle. And angle, side, angle is that first case, right there. That's law of sines to start it off, right? So case 1 is always law of sines. Okay, moving right along. How about the next one? We have ACC. Okay, so if I circle those, A, C, and then the little c is over here. Oops, yeah, little c is over here. So notice how that one is. The side is not between the 2 angles. So that's a side, angle, angle. Right? Side, angle, angle is still that case 1, right? So it's still law of sines. So anytime basically you have 2 angles and a side known, you're going to do law of sines. Okay, finally, we have AB and angle B. So if I circle those, there's A, B, and angle B given. Okay, that's 2 sides and an angle. We call that side, side, angle. Because the angle is not between the 2 sides, right? It's on the outside over there, right? So that's a different case than side, angle, side, like number 1, right? If we knew angle C, that would be side, angle, side. But because we know angle B, it's side, side, angle. Okay, and if it's side-side angle, that's that ambiguous case that we saw last section. That's the law of sines. Okay, so those are all of the cases that you'll run into for these. Just a little practice with that. Now let's jump right into solving, and we'll use those formulas for law of cosines. By the way, if you're curious about where those formulas come from, I'm not covering that in this video, but it's in the textbook if you want to check out the proof of those, or check out some of the videos in the Pearson video log. They'll have it there. Okay, sorry, sip of coffee. Get right into this problem. Okay, so I already drew it out. Notice what we have here is a side angle side case, right? So we have that side given, that angle, and that side. So side angle side, follow these directions here. Okay, it's 3 steps. First, you're going to find that third side using the law of cosines. So step 1, let's just jump right into step 1. Find that third side using law of cosines. The third side is b. Right? So it's b squared equals, and what I'm doing is following this that second formula right there, right? That's what I'm using for this problem, okay? Because I have AC and angle B. So the only thing that's missing is B squared, all right? So B squared is equal to A squared, which is 12.9 squared, plus C squared, 15.4 squared, minus 2 times, and then it's A again, and C again, times the cosine of angle B, 42.3. Right, so there's the structure of that, okay? And then what I'm gonna do is calculate that with my calculator. Let's bring up a calculator and we'll just do it. Now, what I'm gonna do is make sure I'm in the right mode, degree mode. That's good. Okay, and I'm going 12.9 squared plus, it's really, you're just going to type it in just how it looks. So it's minus 2, and then I got to do times 12.9. I don't need to put in for those parentheses like I had it written. Right? Just takes a while to type it all in. And then cosine of 42.3. Okay, and there it is. All right, so that's b squared. So that's approximately 109.69977. And then to get b, you're going to have to take the square root of that number, right? So I'm just going to go second square root. And then actually, I could put in this instead of having to type it in. See where it says answer right there? If you have this type of calculator, I could just hit second answer, right? And that puts in the answer from the previous calculation. And then there's my final answer. So B is about 10.474, or to 1 decimal place, 10.5. Okay. So we can jump back to the handout and keep on going. The next thing you're going to do once we've got the B, so I've got it written out there. Let's look and see. Step 2. So we're right here now. This is that side angle side case. Oops, I don't want to erase it. I want to highlight it. Step 2. And this is the key. It does matter what you find next. You have to find the smaller of the 2 remaining angles using law of sines now, okay? So make sure it's the smaller one. Don't try to find the larger one. We'll just go with that direction right now, and we'll explain why later. But we've got to find the smaller of the 2 remaining angles. Which one is smaller, A or C? Well, it should be opposite the smaller side. So Notice A is 12.9, so angle A would be smaller than angle C, which is opposite the bigger side, 15.4. So I'm going to find angle A next using law of sines. And so I'm going to set up that ratio now with law of sines. Whoop. 12.9 over the sine of angle A should equal to, now I'm going to have to use that B ratio, right? It makes me a little nervous because I'm using this rounded off B. So I'm actually going to use the one with more decimal places, 10.474. For this section, typically, if you're using a value that you calculated, 3 decimal places should suffice. So you can go more than that, but probably a minimum 3 to make sure you're accurate. Okay, so there's my law of sines set up. And then you know how to solve this one because we've done it in the last section. So I'm going to skip a couple of the algebraic steps and just jump to what A equals, right? So cross multiply, inverse sine, all that. You're going to get sine inverse of the cross multiplication, 12.9 sine 42.3 divided by that other side, 10.474. Okay, and then calculate that out. A should be about 56 degrees, calculating that. Okay, and you can verify that. Let me know if that's wrong. Okay, we got one more angle to get, and that's angle C. And I can now do that by just doing the 180 rule. And I think that is the third step, right? So step 3 right there, find the remaining angle using the angle sum formula or that 180 rule for triangles, right? So C is about 180 minus that 56 we just found, minus the 42.3, and that's going to be 81.7 degrees. And there's C. Okay, now the reason why we had to find that A first, the smaller angle first, is because if this angle is obtuse, like if it's more than 90, which it is not in this case, if it's more than 90, this calculation will mislead you. It'll give you an angle less than 90, even though the answer is more than 90. It'll give you the wrong answer. It's just, it's the restriction of your calculator because of the sine inverse restriction function, blah, blah, blah. But so that's the reason. So the key, always get that smaller angle first and you'll be fine. Okay, solved it, we did it. All right. Let's keep going. Let's try this one. This is a side, side, side case. So for side, 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 let's take a look at the steps. Which angle should I find first? Does it matter? All right, so let's look. So here's the side, side, side case. Step 1, find the largest angle using the law of cosines. All right, so, and again, that's going to go back to this restriction of the law of sines. The law of sines only can find acute angles. So we want to find that largest angle using the law of cosines, and then the others will be acute. There's only one possible large or obtuse angle. Okay, so key, get that largest angle. It's important. So find that largest angle first. It's opposite the largest side. It's C, right? So we're going to use the formula that has the cosine of C in it. So you're going to start with C squared. So I'm sorry, I'm going to go back up. We're doing that third formula, right? So I'm plugging into that. Everything except for the angle C will be the variable, okay? So here we go. C squared, 38.5 equals each side squared. Doesn't really matter the order in which you write them. And then times 2 times each of those angles again. And then times the cosine of C. right? Notice that side is opposite that angle. The structure is good. Now you have some algebra. You're just gonna work this out and solve it for C. So one thing I can do is subtract these to the other side. So I'm gonna write this as 38.5 squared minus 22.6 squared minus 25.9 squared, and then leave everything else over here. Okay. And then if I'm trying to get cosine C by itself, I would, well, let's go ahead and just do some calculations here. Let's just go ahead and calculate all this out. So I don't have to keep writing all that. If you calculate all that out, that's 300.68. And then I'm calculating the other side, negative 1170.68. Okay. Now let's try to solve for cosine C. I'm going to divide that negative 1,170. So 300.68 divided by negative that number equals cosine C. And so then what's C going to equal? C is going to be equal to the cosine inverse of that ratio. There you go, nice and sloppy. And then I'm going to put that into my calculator all at once. And I get 104.883 degrees. Okay. Or if I answer to the nearest decimal, 104.9 degrees. There's C. Whew. Okay, we got angle C. Next, back up to my steps for the side case. Find E, the remaining angle using the law of sines. Now it doesn't matter. We've got the obtuse angle, and there is an obtuse, 104 is obtuse. So then we know the other two angles are going to be acute. Doesn't matter which one you find next. And then you'll use the 180 rule to get that third side. Okay, so we're good to go here. I just ran out of room. So let's shrink all this down. And then we'll get some room. Okay. There you go. Okay, now we're using, let's find angle A. So angle A, opposite that is 25.9 sine A. And then I've got to use the C ratios because that's the pair I know, 38.5 over the sine of, and here's where I'm going to use the one that's a little more accurate, 104.883. Okay. And then this is that law of sines steps, right? Cross, multiply, divide, etc. I just get good at this. I just do it all at once. Right. So there's the setup, and then calculate. Plug that into the calculator. I'm getting 40.6 degrees. And there's your angle A. Whew. Okay, one more. We need B. Now you can do your 180 rule. So B is going to be about 180 minus that 40.6 minus the 104.9. And that's 34.5. And we've got it. Okay. All right, so those are the two main cases for law of sines. Side angle side, side side side. Now we can just do some applications in some area. Here we have to find the distance across a lake or something. And we have some surveying here. So the picture describes it all. Okay, so if I'm going to find C, I'm going to use that third formula of law of cosines. Notice this is the side angle side case. So let's set it up. It's going to be C squared equals each side squared. That's a 3. Minus 2 times each of those values times the cosine of the angle. And ooh, the angle is in that minute form. Remember that from way back in the day? All right, that's 132, 40 minutes. So the way we did that before is we just did that 40 divided by 60. All right, that's 40 divided by 60. I got a little sloppy, but take my word for it. Okay. Now I'm just going to calculate that out. Let me make that a little bit better. 40 divided by 60. That's how you're going to type it all in. And that's my dog barking at the door. Okay. Calculate that. All of this is 394,510.5693. And then take the square root of that for your final answer. So I could just square root all of that. And it says round to the nearest meter. I'm getting 628 meters. And that's all I got to do on this one because I don't have to solve the entire triangle. I just needed that C, which I got it. I'm done. Okay, let me take a little breather, have a little more coffee, and I'll come back and in the next video do chapter 4. Hey, not chapter 4, page 4. What am I talking about? That's why I need a break. All right, hope all's well with you. I'll talk to you soon. Bye.